Alright, hi everybody. I hope you guys are behaving in my absence. I'm going to be going over a couple of pages, and I may talk fast because I don't have a lot of storage on my phone. So here we go. First question is, I'm going back to page 9 because I went over that really fast on Friday, so we're going to go over it again so you could pause the video and take notes, okay? So the first question about what could you determine, we learned that this is the A, this is the B, and this is the X. The A is what we call the y-intercept. So with this equation, it's going to tell us that it's going to cross the x-axis at 0, 1. The 3 is our base. What that tells us is that if we have a growth or if we have a decay. Since the number is not a fraction, we have a growth. So that's the stuff that we can determine from this equation. So now we're going to graph it. You're going to make your table using the numbers 0, -1, -1, 0, 1, 2. Then you're going to go to your calculator, and you're going to put in 3 caret x, and then press second graph for your table. And remember, I don't see -1, so I'm just going to press the up button, and it gives me all the other numbers that I need. So we have 0.333, (1, 3, and 9). So now here's this 0, 1. That's our y-intercept that I talked about earlier. So now I'm going to plot 0.333 is in between 0 and 1. Then we have 0, 1. Then we have 1, 3, and 2, 9. I don't know what that is, Mama. If I stop to talk, that's because I'm talking to my daughter. So remember I told you you're not going to connect it this way, but you're going to continue it. Because all exponential functions continue to the left with the arrow and continue to the right with the arrow. So they said, is this graph continuous? Continuous means no breaks, okay? That means the graph, if it was not continuous, the graph would break up and it would be 2 different graphs. But since this is just one graph that continues all the way up, we would say yes. And the reason is because there are no breaks in the graph. There will be times when there are breaks in the graph, just not on this one. Okay, what's the domain? We've got an arrow to the left, arrow to the right. So it's all real numbers. Make sure when you do all real numbers, it's 2 lines. What's the range? As we go from the bottom and we continue to go up, the lowest that it hits is it doesn't have a low point, but it gets really close to 0. So because it gets really close to 0, we have a parenthesis, because it's kind of bouncing off of 0 but never actually touching it. So it goes from 0, which is like here, to infinity. So no more brackets. All right, so they said as you go from left to right, so on the left I'm going to label -infinity, and on the right I'm going to label infinity. So whenever they say left to right, we're going from here to here. So as we travel from -infinity to infinity, where does the graph go? Well, as I go from this direction to this direction, the graph is going to shoot up all the way up to infinity. So they say as the x values increase, what is happening to the g of x values? And you have to say they increase. Just like we did on the other page. But instead, we're saying where they increase to. They're increasing to infinity. Now suppose we were going right to left, so we're starting here, and we're going to the left. That means we're starting up. So it's almost like when you go on a roller coaster and you go up, and then you go backwards and you come back down. So as we come back down, how high is this graph going to go? Well, this graph doesn't go any higher than 0, which is this line. So because the graph doesn't go any higher than 0, we would say they decrease to approach 0. The reason why we can't say they decrease to 0, because it doesn't touch 0, which we learned here. It gets very close to 0. And why doesn't it touch 0? Because it's created something that we call an asymptote. This line here is called an asymptote. It's like a force field. It's like a barrier that the graph gets really close to but doesn't actually touch. It just so happens that this barrier is on the x-axis. So since this graph approaches the x-axis and gets really close to it but doesn't touch it, that x-axis is what we call an asymptote. It is a line that the graph gets close to but doesn't touch it. So we call that line y equals 0. Now, you're probably asking, why is the line called y equals 0, even though it's the x-axis? The name of the line is always opposite of the axis. So if it's the x-axis, the line is called y equals something. Anytime you have a horizontal line, it has to start with y equals. So this pink line here is called y equals 0. We also know it as the x-axis. All right, feel free to pause this video anytime you want, because this was the page that we did on Friday. I just went over it. All right, the next page I wanted to go over was page 11, and then this is where I'm going to stop. Your homework is going to be pages 13 and 14, and then in class you're going to work on page 12. So I am going to be looking at pages 12, 13, and 14, but the hope is that in class you'll work on page 12. All right, so go to your y equals. You're going to put in this equation. So to do 2/5, you do 2 divided by 5. So what we should know from this graph is that the 2 is our y-intercept. So we should be able to cross this graph at 2. And then the 2/5, since it's a fraction, should tell us it's a decay. Okay? So that means the graph should start high and end low. Those are the two things that the graph should tell us. And remember, we learned that on page 8. So press the graph to see if I'm right. And I'm right. Starts high, ends low. Then we press our second graph for our table of functions, and we always use the same numbers. So at -1, it's 5. At 0, it's 2. So there was our y-intercept that I told you about. At 1, it's 0.8. And at 2, it's 0.32. So we're going to go to -1, 5, 0, 2. 0.8 falls right in between 0 and 1, and so does 0.32. So you could put them just like that. Then we're going to continue all the way to the right, because all exponential graphs go from left to right. All right, so now they want us to determine the key features. Before we do anything, we know this graph gets really close to 0. So we want to draw that line that we call an asymptote to make sure that we know where the graph is getting close to but just not touching. So the key features, domain is always the same because we have arrows to the left and to the right. The range, as I go from the bottom, the lowest this graph goes is 0, but it doesn't touch it. It just gets really close to it. So we use a parenthesis. Now, even though this graph is starting high and ending low, when you go from bottom up, it's still going from 0 to infinity. Okay, the y-intercept I circled, that's 0, 2. Say hi to Peyton, guys. All right, get down. And then the last is the asymptote. Remember I told you the name of the asymptote is the x-axis. The The x-axis has a special name, and that name is y equals 0. Has to be y equals because it's a horizontal line going through 0 on the y-axis. Alright guys, that concludes the video. I did page 9 and I did page 11. Remember, your homework for Friday was page 10. And then your homework for tonight is page 13 and 14. Page 12 is classwork. I want you to work on that right now. This video is only 10 minutes and change long. So you should have no problem completing 12, 13, and 14 by the time I come back on Tuesday. Okay? If you're still confused, look on YouTube for videos on graphing exponentials. Okay?
Bye.